Welcome IB Math SL students. We're still working on paper 2 of the May 2018 IB exam, and we're up through problems 8, 9, and 10 in this video. So to start off with, you'll notice that I have two tables, a natural log of x and a natural log of y. And it says that the relationship between the natural log of x and natural log of y can be modeled by the regression equation natural log of y equals a natural log x plus b. Now I do want you to be careful about this. Let's say that instead of the regular old y equals mx plus b, I chose different letters. Let's say that I said that p was equal to mq plus r. So p would be like y and q would be like x. Now the reason that I point that out is because natural log of x and natural log of y are just like my p and q. This is a linear regression. Even though they're giving me natural log of x and natural log of y, imagine replacing the natural log of x with p and the natural log of y with q. Then it would be p equals a times q plus b. So again, it's just a linear equation. Don't let them fool you. So I'm going to go ahead and grab my calculator and stat and enter, and I've already entered all of the data into the list. You can see it there. So I'm going to go quit, stat, right arrow, and I'm going to go down to option 4, linear regression. Hit enter, blah, 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 and here we go. So the values of a and b are exactly what I have in my calculator. Here's a, here's b. So I'll write down that the value of a equals negative 0.454. I'll go 3 significant figures there. And then b is equal to 6.14. I'll also go 3 significant figures there. If you decided to go 6.142 so that you're 3 places past the decimal, that's fine as well. Now the next thing that it asks us to do is use the regression equation to estimate the value of y when x equals 3.57. So let's go ahead and actually set that up here further down the page. So I'm going to say that the natural log of y is equal to negative 0.454 times the natural log of 3.57 plus 6.14. I suppose I better throw in that 2 as well. Okay, let's go ahead and type this into our calculator, just the right hand side. I have negative 0.454 natural log 3.57 close parentheses plus 6.142, and I get 5.564. Now you might be tempted to write that as the answer. It is not, because this is the natural log of y, and they asked us to estimate the value of y. So I need to change this from logarithmic to exponential form. That means I will have e to the 5.564 is equal to y. If you leave it like that, that's probably fine. I'm going to go ahead and put this into my calculator, and I get somewhere around 261. So I think I'll write 261. There are 3 significant figures. All right. I suppose if you had rounded to 5.56 something else, you would have had a slightly different answer, but here we go. All right, now it tells us the relationship between x and y can be modeled according to this formula, y equals kx to the n. All right, so let's go ahead and write this down. So I will take, for part C here, I will take y equals k x to the n. And now we'll take the natural log of both sides, just like it says. So we'll say that the natural log of y equals the natural log of k times x to the n. So now I will go ahead and use the rules of logarithms to break up the right-hand side into the natural log of k plus the natural log of x to the n. I'll do this again. I'm going to rearrange it and move this n out front, so I'll have n times the natural log of x plus the natural log of k, and that's all equal to the natural log of y. So if I compare this to the problem further up the page, I can notice that this is my a value. In this case, it's n, but that means n is just equal to negative 0.454. And then it tells me that this is my b value, so I can write that the natural log of k is equal to 6.14. I will rewrite that as e to the 6.14 is equal to k. I better type that into my calculator. E to the 6.14. I think I'll go ahead and put that 2 in. And there we go. I'm going to get 400, and I'll call it 465. So let me rearrange my paper here. So I get k equals 465. And we're all done with problem 8.